Hello guys, in this video we will see how to perform a fluid structure interaction analysis in ANSYS Workbench. Let us open ANSYS Workbench and just drag down to the custom systems, and inside the custom systems you can see fluid flow, fluent and static structural system. Just double click that. So now you can see a coupled system which consists of fluid flow, fluent system and static structural system. So where the results from the ANSYS fluent analysis that will be sent to the structural analysis for performing a structural analysis. So let us start from the fluid flow fluent analysis first. Right click the geometry and create a new design modular geometry. Now I am choosing the base plane, that is this ZX plane, and click sketching, and I am creating a rectangle. Let us change the unit to millimeters. Now we can scroll down or up to change the size of that. Go to dimensions. In general dimensions, give this as 100 millimeters and this width as 30 millimeters, and go to extrude, create extrude and extrude that to 30 millimeters. Click apply and click generate. Now we have created a block, so it is having a length of 100 millimeters across 30 millimeters and 30 millimeters. Now go to the same base plane, that is ZX plane, and create a new sketch. Click the sketch icon, just aside the sketch 1, and the sketch 2 create another sketch. So this particular domain acts as a fluid domain where the fluid enters from here and leaves out here. So let us introduce a flat plate inside that. So now we have created sketching, and go to the y-axis and click a rectangle and draw a rectangle over here, and go to dimensions. So this rectangle is in a distance of 30 millimeters from the upstream and 70 millimeters from the downstream. So this is the inlet and this is the outlet. And let's give a dimension of a small dimension of 1 millimeters as the thickness of that. So we know that this is having a thickness of 30 millimeters. So let's give a width of 20 millimeters for this plate, and you can right click and drag to zoom in. Let's give a dimension of 10 millimeters from here. Sorry, 5 millimeters here, so that we can have 5 millimeters here, 5 millimeters here, remaining 20 millimeters here. So now this is the plate that we have to keep inside that. So now we have to remove this area from the fluid domain, because that domain should be filled with solid. So we have to remove that area, remove that zone from the solid domain. For that you have to create extrude, not add material, that is removing material, that is cut material. That length is up to 15 millimeters, that is half of the height of the fluid domain, and click generate. So now you can see half of this fluid domain is removed from that. Now go to concept, surface from edges. Now select all these 4 surfaces and click apply and click generate. Now a surface has been created. So inside that there is a cavity. Now go to tools, fill by caps and click generate. So now you can see another body has been added. This is the solid body that we have created. So inside that we have removed some area for the plate. So that zone is filled with a solid body here. So that should be assigned as solid body here. So the first zone should be assigned as fluid and the second zone should be assigned as solid. So this should be named as fluid. So as you can see in this image, this rectangular domain, big rectangular domain is fluid and the small rectangular domain inside that is a solid plate. So fluid is entering into this area and leaving out of this area. So now let's save this file. So now we have created geometry for this analysis. So this same geometry can be shared for static structural analysis of the plate. So now go to the mesh, double click the mesh to open that. Now inside the meshing module you can see two geometry parts. The one is the fluid part, that is the rectangular domain, and the solid part, that is the small rectangular plate that we have created. The main objective of this analysis is to study the deformation of this small rectangular plate because of the force that has been created by the water that is flowing through this big rectangular domain. So now click the solid domain and right click and suppress the body because this is CFD, fluid flow analysis system. Here we need not to have that solid domain. Similarly, while doing the analysis in the structural system, we need not to have the fluid domain. So now we are doing analysis in this fluid domain. So we need not to have the solid domain. We can close this design modeler now. So now I have only the fluid domain. So we have to select the faces which are interacting with a small rectangular plate and we have to provide a name for that. For that I am selecting these surfaces. Click the control button to select multiple surfaces. Right click and create name selection. This is fluid interface. So this is the interface that acts between the fluid body and the solid body. So now you can find this fluid interface inside the name selections. So all the 5 phases that are interacting with the solid domain has been selected. Only the base is not selected because base is not interacting with the fluid domain because the base is to be fixed. And now let's see, now let us name the inlet and outlet. Right click the inlet surface and create inlet. I am identifying this the surfaces based on this direction. So I am naming this the negative side of X is inlet and positive side as outlet. Also while creating the geometry we have created 100 millimeter length and we have allotted 30 millimeters at the upstream and remaining 70 millimeters at the downstream. So this should be the inlet face and this should be the outlet face. So now we have created the name selections. Let's go to the mesh and let's give a mesh size of 2 millimeters and also let us create some refinement. That is refinement should be in the name selection. Already we have named the fluid interface. So near the fluid interface surface we need to have a fine mesh. So I am giving an refinement there and I am clicking generate. So now you can see a mesh has been created. You can observe that because of the refinement that we have created near the plate region we can see a fine mesh, and beyond that there will be a relatively coarse mesh. Now we can close this meshing module, right click and click update, then double click the setup and click start to open ANSYS Fluent. Since we are assuming water is flowing inside this domain, we are going to the materials and going to fluid and double click the air, and inside the fluid database you can find the water liquid right at the bottom of the list. Go to water liquid and click copy and close it. Now inside the fluids you can see air and water. Go to the cell zone conditions and expand this fluid, and we are having only one fluid domain here, and now we can double click the fluid domain and change the material to water liquid. So now we have assigned this whole domain as liquid water. So now we can close this. Now go to the boundary conditions and click the inlet and double click the velocity inlet and just provide a velocity value of 0.5 for our analysis and click apply and then click close. Go to initialization, click the initialize button, double click the run calculation and solve for 200 iterations. Okay, now we can observe that the solution has been converged only up to 10 to the power of -2 for all the equations, and for continuity equation still it is under 10 to the power of -1. So this is not a converged solution. For just for our study purpose this is enough. If you are doing some intense research, you have to go with a refined mesh and get a converged solution. Let's confirm the flow took place properly. Go to the path lines and release from the inlet, and let's click pulse. So now we can observe that the plate is having hindrance and the particles are moving upwards and going outward, and this is one way to confirm whether the flow has been taken correctly. And also we can go to vectors and we can see the velocity vectors, and we have to create a new surface because this is a 3D geometry. You have to create a mid surface, a mid plane. Let's name that as mid plane. That should be an XY plane. XY plane, and the Z location should be, we have created the geometry for 30 millimeter width. So let's change the units to millimeters. Go to units and go to length, change to millimeters, close it, and let's provide 15 millimeters and create this mid plane. Now we can display the velocity at the mid plane. So now we can clearly observe from this mid plane at the inlet the flow is taking place at a uniform velocity, and while it is approaching the plate the flow is deflects over there and it goes in a different manner, and here we can see a recirculation region. And again it goes to the outlet. Now the flow is taking place correctly. Now let's go to the result of this pressure that is taking place at this plate. So go to contours and pressure at the fluid interface and click display. So this is the region where the fluid is having interaction with that plate. So here we haven't taken that plate, but this is the surface where the plate should be. So this is the amount of pressure that is applied. So you can click the right click here and you can see the value, where the value at the center is around 464 pascals and 472 pascals. So at some mid region the value is around 388 pascals and 395 pascals, and at the sides the value is between 258 pascals and 265 pascals. So this is not uniform. So while we are doing a static structural analysis, you will be generally applying a uniform pressure or uniform force over the surface. So but in real case this is not uniform, so this pressure, these results should be taken there to that structural analysis. Also on the other hand, at the other side you can see a negative pressure, so these negative pressures should also be considered while doing that analysis. So by incorporating all these forces we have to do the analysis. That's why this fluid structure interaction is important. So now close this analysis and click OK. Now double click the model. So this is the structural analysis system where we don't want that fluid domain, we want only this solid domain, that is a plate. So here we have to suppress that fluid domain and we have to retain only the solid domain. So for that we have to select that fluid domain and we have to suppress that. Expand this geometry. So this fluid domain is actually water liquid, but this is not required for us. Just right click that and suppress that and click the solid body, and you can see the by default structural scale is assigned for that material. Let's leave that material and go ahead for our analysis. And for our analysis we have to name this base surface because that should be fixed on the base. So click that base surface and right click that and insert. Okay, I have to click this. Click the base surface, right click and create a name selection and name that as fixed support. And we should also name these surfaces. Select all the other phases. These all other phases will be interacting with the fluid. So these surfaces will be receiving the forces or pressure from that fluid that is flowing. So select all the surfaces and right click and create name selection and name that as solid interface. Similarly, we have named that interface in the fluid domain as fluid interface. So now we have two interfaces. One is solid interface, that is now we are assigning, and the fluid interface that we have already assigned there in the fluid analysis. So now in the name selection you can see this fixed support, that is at the base, and the solid interface, that is all other 5 surfaces. You can see 5 faces there. Okay, in the structural systems already we have give the fixed structural analysis. We have to give a fixed support. So go to insert, provide fixed support, and go to the geometry and give the name selection. Already we have named the surface where the fixed support is to be provided. Go to that, select that fixed support name, and also go to the solution, right click and insert. We need the deformation, and also we need the one measure stress. So these are the two results that we need to analyze, and we have provided one fixed support, and the force that is being acted here is not provided by us. That should be taken by the imported load from the CFD results. That is from the CFD results. So right click the imported load and insert pressure and select the geometry, that is name selection. Already we have named the surface as solid interface. So solid interface is the surface where the pressure is to be applied, and transfer definition from the fluid interface. Fluid interface is the surface from where the pressure is to be taken. So that is already defined by default. If you want, we can also change the surface. So it is already defined correctly. So I am leaving that as it is, and I am clicking solve now. Okay, now you can see the deformation results. So if you click this play button, you can see the animation of that thing. This is not a transient analysis, this is just a static structural analysis. The only difference or the only beauty in this analysis is the force that is offered over the plate is not given manually or not given by us. The force or the pressure that is acting over the plate is given by the CFD results. So we have run a CFD result, and from the CFD results the solution has been taken to the setup, and the results from the CFD result is taken as input for this structural analysis, and we have done the so as we have given at the base the structure is fixed, and at the top we can see the maximum deformation. Similarly, if you want to see the stress at the base, that is fixed, so since it is fixed, the maximum stress is being acting over there, and at the end the stress is very minimum. So I hope this tutorial helps you. This is just a static structural analysis, and this is a one-way fluid structural interaction. So in a similar way, we can do a two-way fluid structural interaction. That means the deformation that is taking place here, that should be imported to the CFD analysis, and then a CFD analysis is to be run, and the deformation and the deformed body is taken for the fluid flow analysis. So that is two-way fluid structural interaction. So maybe in the future we will see that in our future videos. Thank you. Hope this video helped you. Don't forget to subscribe.